Okay, how to give your robot imagination. I hate this picture. This is like one of the, they always look like that, but they never actually work like a human being. Next slide, please. Okay, so what is imagination? We're talking about imagination for robots. Imagination is the ability to form new images and sensations in the mind that are not perceived and through senses such as sight. That was good. Okay, next slide, please. So in a robot domain, robots have sensors rather than senses. They're not the same as human senses. Smell and taste are not usually found on a robot, not even this robot, Big Dog, by the way. Next slide. Next slide. Okay, so the world view of a robot is very different to ours, very, very different. Robots detect many things human beings cannot detect. And this is the horrible live demo. I hope this is going to work now. Do you hear that? No? It did work. Okay, so basically this is a NFC tag. Now this you can use in a robot, but we can't pick it up when we do that. Next slide, please. So robots can have a lot more sensors than humans have senses. So this is actually a Raspberry Pi sense hat. It has 6 sensors built in. This is the one in the space station, by the way. I've got one here so I can show you afterwards, and it's even got like a mini joystick there. So it has 9 degrees of freedom, you know, accelerometer, etc., pressure, humidity, temperature. But we're not going to put it in your garden, so you're okay. Right, next slide, please. So it's different to human hardware and software. There we go. There's the phone. This is an old phone I use for demos. Sensor data from the real-world physical events is usually converted, analog to digital converted to electronic digital information, sensor readings, and then it's processed with a digital computer, mobile phone, or whatever. Next slide. Okay, next. So, when did the sensors produce that data? You need a timestamp. That's really important. A lot of microcontrollers don't actually have a real-time clock, so they're not able to know exactly when something happened. So we need to stamp, okay, the events happen at that time, and you need to store that data. And as we've heard, it's a lot of data, and it's a real engineering challenge to make sense of all that. Okay, next slide. So the real world is not the internet. It's an open-loop system. We're not going to be coupled to the internet if we're going to move around in the real world. Okay, next slide. So now we get down to the interesting stuff. How do you create an imagination? Techniques, please. So the simplest technique is you imagine a higher or lower sensor reading than you've previously got. So you take a reading and then you imagine, oh, I'm getting twice the normal rate or something that you've never actually had. Going for humidity, for example, if I've got high humidity, imagine your Raspberry Pi's been left in the rain, your humidity sensor might register that. If you get a very high reading, that's what happens when you put it in the rain or something. Okay, next slide. And now, Charlotte. This is true story. Charlotte, an old friend of mine, had synesthesia. She mixed smell and color, so she'd see something, and she'd go, oh, that's a purple smell. And this is known as synesthesia. She actually mixed up her senses. So she took in a nose, and then she saw color. Okay. And people can mix sound and color and get a blue note. This is quite common. And it's a bit like the old electronic sound to light in the 70s disco. You remember? I was there, you know. So this is an Atari one. Ah, I see you there. Okay, next, right. So what happens if computers mix sensor data? So you take in some data from one sensor and you imagine that it was through another sensor. The same idea as sound to light. So that's like synesthesia. That's like getting new information, a new scenario. Okay, next. So also you can detect patterns, sensor readings at this time. Is it one-off or is it every 5 seconds, every day or something like that? So you can see if there are sequences of events and then patterns can be detected. So that's another way. Can I actually think that that's going to happen next week or tomorrow or something? Okay, next one. So recurrence, events, sensor readings can repeat. Basically, we use learning sequences and patterns and help predict the future. So you actually can, in a concrete way, do something. Okay, next. So you can also have what's called sensor fusion. If you bring in more sensors at the same time that you've got these two sensors, you can put another one, and then you're processing several associated sensor data streams at the same time. And you can get a magnetometer and a camera readings to a temperature and a pressure sensor, humidity sensors. I'm going to show you a color camera afterwards if you want to see one. So when bad weather, you might even be able to detect with a magnetometer lightning flash, stuff like that. Next slide. Okay, so summary. Imagination techniques. You can simulate a value, you can process from one sensor as if it came from another, and you can just associate more sensors together, sensor fusion. And here are some examples. This is you can download all this, so you don't need to take pictures, it's all there, and I've got live links as well. Next. So that's it. So the conclusion, the robot takes real-world sensor readings in its own domain. Concepts are derived from these readings and sensor combinations, and these concepts are combined to form more complex terms. It needs a machine language to describe this, a new language. These concepts are modified values, and they're not taken from actual reason, but imagined. So this is just the basics, as I said. It's a challenge in engineering, but with this, you could exchange information between systems. Okay, thanks. And thank you.
Very nice. Thank you, Stuart.